Assalamualaikum warahmatullahi wabarakatuh. Hi everyone. Today we're gonna learn about network in graph theory. Before we start our lesson, we need to know what is the relationship between a network and a graph. So basically, a graph is usually used to represent a certain network. A network is a part of graph with the vertices and edges having their own characteristics. So, what is the vertex and edge? Vertex is the dot signs and edge is the lines. Now, we look back at our previous slide. As you can see, there is a picture of land transport network. For this example, the vertex are regions, towns, cities, or certain buildings that are linked, and the edge are roads, highways, or railway lines. A graph can be denoted by a set of ordered pairs. V is the set of dots or vertices. E is the set of edges or lines linking each pair of vertices. What do you understand about a simple graph? A simple graph has no loops and no multiple edges. The sum of degrees of the graph is twice the number of edges. For the example, the vertices are A, B, C, D, E, F, G, and the number of vertices is 7. What about the edges? The edges are A to B, B to E, E to G, G to F, and many more. After we found the number of edges, we can times it by 2 to get a sum of degrees. Okay, let's do this together. First of all, we need to find all the vertex. I got V equal to curly bracket 1, 2, 3, 4, 5, curly bracket. Now, we got the total number of vertex is 5. How about the edge? E equal to curly bracket 1, 2, 2, 1, 2, 4, 1, 2, 5, 2, 2, 3, 2, 2, 4, 3, 2, 4, curly bracket. So, the number of edge is 6. The last step, we need to find the sum of degrees. The number of edge times 2. So, the sum of degrees is equal to 12. Easy, right? Now, we move to multiple edges and loops. Multiple edges. Multiple edges involve two vertices. The vertices are connected by more than one edge. The sum of degrees is twice the number of edges. Look at vertex A and B. There is two multiple edges between them. So, we call as multiple edges. Look at the way I denoted vertices and edges. V equal to curly bracket A, B, C, and curly bracket again. We must know how to denote vertices and edges because in our exam, we need to do it correctly. If you look to the denoted edges, you can see there is 2BA. Why there is double BA? Because there is two edges that connected by the same vertices. After that, we need to find the sum of degrees. The number of edges times 2. As example in our slide, 2 times 4 equal to 8. Loops. Loops involve one vertex. The edge is in the form of an arc that starts and ends at the same vertex. Each loop adds 2 to the degree. Look at the edge. There is C to C. This is the correct way to denote loops. Move to the next slide, directed and undirected graph. Directed graph, a graph in which a direction is assigned to the edge connecting two vertices. Look at the arrow. That is the way we represent directed graph. Undirected graph. Undirected graph is a simple graph or a graph with loops and multiple edges drawn without any direction being assigned. As you can see, there is no arrows in that picture. How we denoted directed graph? The order of the vertices are written according to the direction of the edge. Look carefully how I denoted edges of directed graph. It should be B to A, C to A, B to C, D to C. To be more clear, the order of the vertices written is not important when it's come to undirected graph. Both pairs of vertices AB and BA represent the edge AB. Look at the example that I show you. You can write your edge A first or B first, that is not important. Next, a subgraph. Subgraph is a part of a graph or the whole graph redrawn without changing the original position of the vertices and edges. As you can see, G1 is the original graph. No matter what you draw back your graph, do not change original position of the vertices and edges. Lastly, tree. What do you understand about a tree? A tree of a graph is a subgraph of the graph with the following properties. First, a simple graph without loops and multiple edges. Second, all the vertices are connected and each pair of vertices is connected by only one edge. Third, number of edge equal to number of vertices minus 1. Number of vertices equal to n. Number of edges equal to n minus 1. Look at the picture. The right one is a tree, but the left one is not a tree because the vertices D and E connected by two edges. That's all from me, Farah Izzati. Thank you for watching.